through Morosky, advanced. I'm sorry. It's titled Advanced Transportation Processes. Since these were not advanced enough, we have to find out what these
Actually, the title is and their applications for the decontamination of radioactive nuclear waste. I was comparing the, how can I say, the conventional transportation systems that the Oak Ridge National Laboratory people talk about and the Swedish government, the Japanese government talk about for nuclear waste. And we're trying to compare those with new ones. So that's why it's called advanced. It was, actually this is a result of a paper that I made for the Canadian Environmental Assessment Agency last year. Now, that paper, by the way,
what do you do at the back?
I'm sorry.
Yeah. Oh,
yeah, thank you.
Yeah.
First of all, I want to express my delight at the quality of speakers and the organization. This is the cause for the fact that I'm going to go quite differently from the paper as I have printed it, and which will appear in proceedings, in order to give new material which will be helpful, I hope, to give process and evolve these presentations I've heard today. Now, the paper as originally written tried to explain that it is already known in solid scientific literature that decay rates of radioactive materials are not as holy and as they have been as they appear in certain books. And that the leading research in that area for radioactive materials has actually been in the Lawrence Livermore Laboratory since the 1950s, where there must be about 30 different papers that show how chemical and also environmental impacts can influence the normal decay rates. So the normal Bohr-Rutherford model of the atom and its decay is not a holy thing, and that is, and I give all the citations, at least 25. Now, the next aspect was to describe the fact that there's another body of literature which in some circles appears to be controversial, depends which country you really are in, and in others is not considered to be controversial. This body of literature relates to low-energy transportation processes in living systems, especially plant life. The first person to note that there was something unusual is a very famous chemist in chemistry, Nicolas Louis Vauquelin, who noted that hens would excrete 5 times more lime than they take in as food. And so therefore we see a transmutation of calcium carbonate. This type of literature led a very prominent scientist in the National Research Council of France, Professor Louis Terrebonne, to assemble this information and then find what he thought were flawless experimental evidence of what was happening by taking ashes before and after whatever transmutation was taken into consideration. And he was not happy to have such results only done in France, but had them replicated by the equivalent, not in name though, National Research Council of Switzerland. Now, the evidence was so strong that this created a tension, I would say, with some nuclear physicists And one man came along, a Nobel Prize winner, Olivier Costa-de-Beauregard, who tried to explain that this was possible, the evidence that was presented, by depending on the recently developed, at that time, we're not talking about the 70s, concept of mutual currents, for which people have, Abdus Salam and his colleagues had received the Nobel Prize. And that was that you could have the neutron developing into proton or electron plus a virtual particle. But he added that there were two neutrinos possible, resulting, that's now Costa-de-Beauregard, from these such transformations. And one of them would allow for freedom to attach to any atom. And that this is the motive by which it is possible to attract and create new chemicals. I'd like to make very clear ahead of time that I am not presenting to you work from the bench. I'm only here as a compiler of information. And I hope that I can present something that will eventually be of true use to all of you. Now, among my colleagues, one of the founders of our association is he's died recently, Dr. Bockris. Now, Bockris is not known for this, but he's the inventor of the hearing aid. He's also developed a lot of research into electrical resonance because he was asked by the United States government to start working to analyze the work of Nikola Tesla. And among the non-published work of Nikola Tesla was electrical resonance. And this led to the hearing aid that we now know, and also, of course, to the famous weapon devices the world's full of, and of course the ultra high-quality detection system used by satellites and other remote viewing systems. All came from Bockris, basically. Now, Bockris has had access to a high-quality microscope originally developed in France and applied in Canada, designed by Gaston Naissance. It was a dark field microscope that allows you to see in vivo transformations as they occur, and also to see, for example, live blood samples. Mr. Bockris, among his different researches, had developed an electrolytic system which is described in one book that we sell called on the first International Symposium on New Energy Technology. And he was amazed that as electrolysis was taking place and seen through an in vivo microscope, he could actually see in sequence changes taking place, either in organic chemistry or in live systems. And the changes were so spectacular and so easy to replicate and photograph constantly with no problem that Andrea said, God, Caravan is really talking about biological transportation. As a matter of fact, Andrea felt in one serious experiment he actually was able to create life from organic compounds, just from a seeing happen. But the main thing is that the transformations show, just like many of the reports you have been hearing, there literally changes from assays later on in the different new molecules or new atoms of a plant, which was very disturbing because, just like I hear indirectly, it's not stated explicitly, but almost all of you, when you're working with your cold fusion work or whatnot, you're always asking, like, is it possible that there's something dirty, either in the electrolyte or electrode and so on? But when you see it in the living process with this microscope, and you can buy it now for $2,000, attachment to move microscope, you'll be actually able to see in the electrolysis the transformation taking place, second by second or millisecond or whatnot. This is very good. The upshot, and why am I talking so much about that particular thing, is that Bockris, after 15 years of watching through a microscope, was convinced that yes, the caravan system really exists, and that perhaps, as far as he could see, he saw no evidence to the contrary. Costa and Bockris touched on the right thing. It is the neutral currents that are responsible for lots of things. Another interesting example of natural transportation is a beautiful piece of work done after World War II by the British Research Council, scholarship from the laboratories, where it was noticed that the radioactive isotope 203 of mercury was ingested by rats and completely volatilized. So here you have some system whereby the digestive system apparently of rats was able to conduct transportation. I do not need to talk about cold fusion example, which I cited from the Environmental Agency. And of course, I do not have to talk about low temperature transportation as demonstrated by Dr. Alapsi of the Korean. What I am going to do today, and I think it will be useful to all of you, is to go much more deeply than was originally intended into the work of the Bulgarian scientist who's known as Yul Grau. His real name is Ilya Repov, and who, inspired by Yul Grau and also Bible, did the research he actually did. In the Bible it says the world will end in fire, and here you have a Bulgarian monk who said, how can the world possibly burn if the surface of the earth is 70% water? You know, like this. You know, if the Bible is saying the truth, there's something going on here that has to be explained. And of course, the other inspiration was Yul Verne was insisting that perhaps one day the fuel will be water. Well, what Yul Verne did, essentially, was to design a system very similar and done in the same years, basically, as that designed by Dr. Bockris, which is a submerged water electrolysis system. And in both cases, it is the phonon effect taking place, in which you have a frequency generation or a frequency, multiple frequency generation used to allow for the composition of water. What is unique, however, in the system of Yul Verne is that what comes out of the electrolysis is a safe stoichiometric mixture of oxygen and hydrogen. And I did not realize until a few days ago, having gone through the editing of a book by Hal Koda, which our association has assembled, called 0 Point Energy Research. And Bockris, by much of the work I've heard today, including that of Mr. Shoulders, and the first two speakers this morning, is this business of stoichiometric mixture. Now, in the Yul Verne system, the stoichiometric mixture has only a 5% tolerance, in which what happens is that if the gases are in that combination, and if they are sparked or they're made to burn, they do so non-explosively. And if you have this in a container, the result of the combustion will be a vacuum or an implosion fluid. Now, now, I am not a chemist like many of you are, or who have the knowledge you have. But my interpretation of the stoichiometric mixture means, in my mind, right, if I'm wrong, please, somebody do the courageous thing and tell me that I'm wrong, means that somehow the atoms of the hydrogen and the atoms of the oxygen are at peace with each other. They are balancing perfectly, that they do not need to do any other bonding elsewhere. There is no free agent that can work beyond that. If this is true, like there is this molecular, if you will, peace, well, this is, in my mind, very similar to a physical model of zero-point energy, in which zero-point energy is supposedly for physical systems. The state at which you have already excluded all the known all the known energy systems, and yet you still have a core peaceful system that is stable. And if you disrupt the zero-point energy system, then suddenly you get unleashed tremendous amount of forces. Now, perhaps if I'm right for the molecular system of your ground, we now have a peaceful chemical system, and if you disrupt it, you are allowing a tremendous influx of energy like in the physical model. You can create fluctuations of vacuum energy. You can create electron clusters. You can create endothermic and exothermic reactions, which we've been reporting all over. You're allowing for new bonding of the neutral current to suddenly take place. Now, let's go back to the ground a little bit further. Now, in the original presentation I made, when Neil Brown was invited by the Chinese government to transfer his technology from Australia, and the units, the units that Neil Brown had worked with in Australia were very similar to this one here. Like, in fact, Mr. Bockris, Professor Bockris remembers it. It was way back in the late 70s, I believe? Yeah, something like that. Yeah, in which you have basically cells. In this area, you have these electro-wet cells, about 8 of them in this particular unit, stacked together, and they produce out of it a safe mixture of oxygen and hydrogen coming out, and the rest is just command and control features. Now, the Chinese replicated this technology of Neil Brown within months, and that was, I think, in the early 1990s. And already the technology proved to be so fruitful that there's one factory which used to produce locomotives that produces these generators. And there are 14 more factories that produce applications, of which only 2 are not secret. The one that is not secret, and that the Chinese told you about a few weeks ago when you came to Los Angeles to see him, involves an aspect of your Brown's technology, which is that when the gas is exploded, is ignited, it produces a vacuum. So what they have done is they take the water that is used, seawater in ships, that is used to cool down the propeller shafts, and which rise in temperature 30 degrees Celsius, to be used at 30 degrees Celsius, input it with this gas, and that will allow for a vacuum to be created, and there is have an instant evaporation of that water, and you distill it in the clean water. So there's no ship now in the Chinese military or maritime fleet carries water anymore. They use ground gas to produce clean water on demand. Now, the laboratory that decided, the company, that decided to make these, a few years ago in 1991, conducted tests to see what would happen if ground gas were to be exposed to cobalt-60. So they did 2 experiments that have been published, and one which the original intensity was 580 milliamps per hour, and the other one had a small 115 to 120. And then after treatment, it would go the first one went this way, and then they got it to decrease to this, and then they got it back. So you had, after 2 treatments, you have a decrease from 515 milligrams to 42 milligrams per hour. And that's one thing. When Mr. Brown came to the United States, this kind of work attracted the attentions of some people, and one of them was a congressman who describes an experiment that was done not to the scientific community at that time. There was no interest in the scientific community, nor with the Department of Energy, but this congressman was with the Energy Committee, and he says the following, that Mr. Brown used a slice of radioactive americium. Brown melted it together on a brick with small chunks of steel and aluminum. After a couple of minutes under the flame, the molten metal sent up an instant flash, and what Brown says is the reaction that destroys the radioactivity. Before the heating and mixing with the other metals, the americium made by the decay of an isotope of plutonium registered 16,000 curies per minute of radiation. Measured afterward, the mass of metals read less than 100 curies per minute, about the same as the background radiation in the laboratory where Brown was working. So that's one situation. I have asked several times you to tell me what are the results for different radioactive materials. He gets very nervous about this because he, first of all, does not have the facility that some of you enjoy, so he can prove it without insurance all the time. But the problem is that to achieve a regular, repeatable experiment for everything is not as easy. It takes time. Like the first time that you ever did cobalt, it was like you see here in China. The first time you tried China was only 60% reduction. But it is that hard work of mixing with matrices of meshes and stuff like that, mixing with the appropriate types of, say, silicates, the appropriate metals and scraps inside, that finally allows you to make even in one shot that flash, for example, that we have just heard of, a 99% reduction in radioactivity. Okay, now...
3 minutes.
Thank you. So, the other aspects of Brown's gas which I found comparable to what I've been hearing is that the gas itself has its own dynamics. It comes out of the generator with a pressure, there's a flux, there's a turbulence, it is produced in pulses. So are we dealing with a plasma type of situation at not high temperature? And also, if you look at any samples that Yale Brown worked with for any purpose, you see anomalous distribution of what we've been hearing about, like clustered electrons. And these anomalous things sometimes are helpful. There's nothing like seeing Yale Brown, and I've seen it several times, bond aluminum with aluminum with just a blank. Or, as he did for some people, I think there's some here in this room too, where you can bond a nail to a brick or a piece of concrete and hold out the concrete like that with no other material. In order for anything like that to happen, one has to assume, at least I do, is that the two ends to the joint have to have some transmutative process allowing the bonding to take place. Like aluminum, it's not aluminum really bonding with aluminum, that's not possible. And it's not really the steel that's bonding directly to concrete. It's that the concrete has evolved at the surface to something, and the steel nail has evolved to some melting process, and it is data that are put in the bond. That's my interpretation of things. Now, the other process that was described for the clean environmental assessment agency is something that, again, some people in the audience have a good knowledge of, and that is an unexpected anomaly that took place for some of our members doing experiments of completely different nature, and that is experimentation with what's called non-Hertzian electromagnetic fields. Now, non-Hertzian fields, as far as I know, were first described reasonably well by Mr. Nikola Tesla. And if you ever want to know what Tesla really meant by this directly, one of our colleagues finally found the legal deposition that Tesla made for the United States government to help defend the United States against the Marconi patent. And there he describes how he did the transmitter and produced the non-Hertzian fields. Yes, I will do that, so shortly. And that's given great detail, as well as in the warp drive system. But there also are other people who talked about non-Hertzian coils, for example, and of course Toby Woods has worked tremendously in this area, is where you're trying to make fields, for example, like that, where you're trying to do everything you can that they're completely asymmetric in the sense that one direction will cancel out the other. So you have canceled known electromagnetic fields, but yet you're producing some, whatever, radio frequency, whatnot, coil. Now,
could you get to a conclusion?
I will, don't worry. And what happened in experiments of this nature, they were usually done in laboratories where there could be some piece of radioactivity in the lab. And you would have, depending on the experiments conducted with such coils, for example, either an increase in the radioactivity of the samples in the present or a decrease. And then it was found to be dependent on the waveform involved and the frequency. Now, going back to this concept, is that if you have, in one idea, two scalar emitters, one say with a positive bias and one with a negative bias, and you want to interferometrize at a distance some nuclear material, that you could be able to do a decontamination of something at a distance. Now, I'll just say the following to end. I'm sorry it's so short. The U-ground system has the beauty that it can be put on a robot and go to the site that has become contaminated, either for toxic waste or nuclear waste. Hence, it's a completely robotic system and does not require the transportation of anything. You just work on it, whatever it is. And that's nice too. And we assume, knowing that the best results that you have been able to do were machines were 4 times the size of what I showed you the picture of. That is 16 of these cells. I'm sorry, 32 of these cells. Then you have enough flow and PSI to work with. That means that you can have decontamination plants that will cost less than $1 million a piece and could do hard work. In this technology, the coils can cost anywhere from $1,000 to $5,000 a piece, except that the process is much longer. It's not instantaneous. Thank you very much.
time just for 2 questions.
You mentioned somebody, Bockris and Sons, biological transmutation that you claimed he had done. What was that?
What was the biological?
You said that he'd been observing some biological changes.
Yes.
I thought you implied
one of the systems that he worked with were saline concentrations. This is probably what we have to somehow. Yes, you would have saline concentrations electrolytes, and he would know whatever he started out with. He had a very good spectrometer for that to check things out, and then he would see slowly fractal developments taking place. First of all, clustering, and depending on the frequency you work with, say if you have 8 hertz or 10 hertz or 15, then there will be clustering followed by fractals, and eventually you may have systems that start to take a life, that you want to start seeing movements and so on. Okay? That was one situation. What had made him think about this was that Gaston's Mason's discovery, what he found in his microscope, was that he would see in blood samples what, according to his microscope, was the smallest living thing possible, called somati, after the Greek word small. And you could find nothing smaller than that you live and so on. And it's usually found in sap and in blood. That this system could evolve into bacteria and so on. That's the logic of Gaston-Mason's. What Mr. Bockris wanted to know, can I reverse that? If, for example, I see a dangerous virus clearly from the blood thing that he could create, can I reverse it? And he did by frequency. All of it. Is that okay? I'm sorry if I'm not a little bit too far.
I'm interested in the cobalt-60 experiment. Your units aren't of activity, they're actually of dose delivery. So here's my question. How do you know when you do the explosion, implosion, whatever it is, that you're not changing the good geometry of the system?
That's what the Department of Energy people stated. They couldn't give an answer, like they were left in a situation where they found a 99.6 activity in some things. They thought, God, this must be in the air, so they brought it to see the California health officials, and they found nothing in the air.
Is it done in a closed container?
It does not have to be done in a closed container. It can be done. Actually, the Chinese experiment was done in closed container, but they eventually went to plutonium, they went to uranium, and deal with all that, including more radioactive stuff, because first we were scared of uranium, like one of the weakest possible samples we had. But eventually we got the whole slew of radioactivity all over the planet. And they had to do it under almost like your heat tank, under 2 or 3 years there.
So your report to the Canadian government recommends that they start processing this one?
Well, the Canadian government, what it did, when it got its first, this is the second report, you see, they ordered Atomic Energy Canada to consider transportation as an alternative. That they were not, that they had, the government had to look at transportation. Well, what they started up taking was this Bockris, National Laboratory, Swedish stuff, and so on, and that's where we said, hey, that's not transportation the way we mean it. We mean real transportation. Well, and that's why we call it advanced and all that. I'm sorry, I was not trying to slur anyone in this room.
Thank you. Mr. Colback, due to personal reasons, phone said he could not come.
Ladies and gentlemen, I just want to ask for a head count of who's going to be here on Saturday night. Would you, people from out of town, raise your hands, please. 1, 2, 3, 4, 5, 6, 7, 8. Any more? 12. Well, people here.
Okay, now we're beginning the theoretical model section. The first talk is Professor Kim from Purdue University. His title is Nuclear Physics Mechanism for Gamma Factor Cancellation in Low Energy Nuclear Reaction. Yes, I guess when you talk, maybe.
Gentlemen, come on.
You hear me?
Yeah, I guess. Yeah.
I can't hear myself.
Okay, no. Not
That's what.
it's on.
Huh?
It's on.
Huh? This is an abstract I sent in for this conference, and 3 of those papers published. So if you have any detailed question, I can provide with those papers. We have been looking at way to overcome conventional formulation of quantum scattering theory applied to nuclear physics and try to understand or come up with better description of all of these anomalies. I will not talk about this because our formulation does not apply to this yet. The first approach we looking at is this strong interaction mechanism, and we are looking at electromagnetic interaction as well as weak interaction. Those two are in the process of being developed, so I won't talk about it at this meeting, but maybe next time I'll talk about those. So today I will concentrate the strong interaction mechanism mostly. If you look at the way conventional theoretical estimate is done for cold fusion phenomena, it's essentially based upon quantum scattering theory. And I won't go through all this algebra or showing what it is, but essentially you have two channels. One is the elastic channel, and the other is reaction channel, where fusion reaction is one of them. Normally, you can write down this kind of formula. If you have two potential, strong nuclear potential, and then since it's the incoming two particles of charge, you have to always put the Coulomb interaction. And this is standard way it's developed. And if you look at the quantum mechanics book, these are written down. And the way the fusion cross-section is estimated is essentially take this formula and substitute by transmission coefficient. And this is called the astronomical aspect. And usually you take lowest L equals 0 state, and then transmission coefficient turns out to be so-called gamma factor. And as you know, gamma factor can be obtained a number of different ways. One model which gives gamma factor is this very simple model where you have a Coulomb repulsive barrier, and if you make calculation of transmission coefficient, then you can get gamma factor. And formula out of that simple model is famous gamma factor. And if everyone is using this gamma factor in astrophysics, and the people who object to most of cold fusion data is essentially using this gamma factor to say that's impossible. And the reason why they are saying is that if you look gamma factor, it's astronomically small. As you know, at the room temperature, gamma factor, this is essentially probability of bringing in two charged particles into top of each other, and that's astronomically small. Even if you put the screening, the Thomas Fermi screening model will be sort of optimal screening case, and even then, you end up with this kind of number compared to what is being observed or claimed. So there are 20 to 30 order of magnitude discrepancy, and that's why scientific community or nuclear physics community won't accept this fact yet. And of course, this is a similar number. In terms of deuterium, these numbers to be compared. So these are reference numbers I like to mention. And the question is this model really that rigorous? To me, it's just model. It's not a fundamental derivation given. It's a simple model which seems to work at high energy. But no direct measurement of cross-section at low energy, like 1 kV below, exists. So there is no experimental confirmation that the gamma factor will essentially hold on down to 0 energy. So we looked at improvement of scatter improvement, and we introduced the optical theorem. And again, this is not given in the textbook, but you can go through this algebra and end up with this theorem. And this is rigorous as conventional optical theorem. Conventional optical theorem relates total cross-section, which include both elastic and fusion cross-section, to forward scattering amplitude. This is well-known conventional optical theorem. But if you have a Coulomb interaction between them, this says a Coulomb amplitude, which has a singularity at the 0 forward direction, so you cannot really use this theorem. So we had to reinvent optical theorem with all of the angular integrated quantities. And this derivation shows it's rigorous, and obviously this is coming from conservation of flux, which is one of the fundamental theorems. So taking this relation and knowing that at the low energy, this is much larger than elastic cross-section, you can get this nice formula, which can apply to polar fusion regime as well. And what it says is that if you want to find out fusion cross-section at the low energy, like polar fusion regime, you can simply relate that to imaginary part of elastic scattering amplitude. Now, question then becomes, how can you find such a quantity? Once I know how to calculate that, then I can get a real process. So the way we approach this problem is to look at the imaginary part of elastic scattering amplitude. So this is the same formula, and imaginary elastic scattering amplitude can be written in this form theoretically. So that this goes in here, and of course you don't know this until you introduce more fundamental theory, which is pretty hard because we're talking about nucleus consisting of many particles, a many-body problem which no one can solve exactly. So what we did was to look at parameterize this form, and let's assume that this function is given by essentially this Yukawa form. It has a range, and it decays at a large distance. So this is completely different approach than the previous approach. And what's interesting the point is that if we make a very complicated function out of that by multiplying a polynomial, you still get this formula. That is, remember, this is a conventional gamma factor. we get this so-called enhancement factor even with this complicated form, regardless of what these parameters are. So this formula appears to be quite general formula. Even if we don't know precise form of this function with arbitrary parameter, you still get this factor. And this is sort of what you get out of that. So compared to this conventional formula, this is a new factor. And remember, this factor is not pulled out of air. It's coming out of derivation with this particular parameterization of imaginary part of amplitude. So that was our main point of using this formula for cold fusion. And I'll address how you can have a gamma factor cancellation for particular cases. If you take this form, which we derive, which is quite general, independent of what form factor we assume, it goes to gamma factor with the opposite sign in this limit. This limit means you have a long-range tail in the Yukawa form, that is this type of form. Essentially, approaching 1 bar, you make a 0. But of course, in reality, you never reach that because strong interaction will never mimic Coulomb function exactly. On the other hand, if beta is sufficiently small, you can have a near cancellation. And if indeed that happens, even though this part is extremely small, let's say this component compared to shorter range part is extremely small, this term can kill off gamma factor with full force. So it's quite possible that might happen. Now the question becomes, can we really have that kind of range? Well, before I do that, let me show you what kind of cancellation you can manage. Suppose beta is, for this case, deuterium DD or D palladium case, is this large. This is a Jones level, this is a freshman Pons level. Then you can get what the experimental number, that is freshman Pons here or Jones level. And what's more interesting is that you need not to limit yourself to D plus D. You can have a D plus palladium or D plus any other nuclei. And of course, you can have a proton plus palladium. Remember, formula I introduced here, you can pick the charge of incoming particle and target particle, and that will give the same behavior, although magnitude is different. So this may be one way out of dilemma with a conventional estimate when we talk about transmutation. Now let me try to justify whether such long-range force can exist in nature. Recently we published a paper in Physical Review C. It's not published, it's going to come out next month. I won't go through all the algebra. I can give you proof of manuscript to you because it's not published yet. I don't have the actual published version. But what this paper does is, based upon three-body formulation, like this case, I picked an example of BP reaction. Remember, this was Oppenheimer-Philip type process. So there are two channels, and we formulate three-body formulation. These are all kinematic and so on. Because of time, I won't go through the algebra, but the main conclusion is that we can get the long-range force. This is final state. Of this type. Remember, this is the function G I talked about before. That's the one we are dealing with, and it is for the P wave hello state. I have this similar parameterization, and beta essentially represent so-called halo nuclei. It's a loosely bound neutron core type nuclei, and if that beta is extremely small, then we have that limit of beta going to 0, which I showed before. So this is very relevant to what I was saying before. And derivation is very rigorous, but assumption is that there is halo excited state in the final nuclei. For instance, palladium case, you do the DP reaction, and you go palladium, let's say 105 to 106. That would be one example. And if 106 happens to have excited state, which has a very small binding energy, then gamma vector translation can occur. Now, you may ask, do we have such a state observed? And not yet. In light nuclei, there are lots of examples. This is a heteronuclei example of lithium-11 is twice as large as boron-11. And the reason is that those two neutrons is like a neutron cloud. It's loosely bound. They are hanging around, but not very tightly bound like this. So the RMS radius is twice as large as that. So this is one example. Another example known to me, there may be more, with neutron plus core nuclei. Those examples I'm showing you. And I'm telling you that there is an example of excited halo state already known to us. Now, for the heavy nuclei, we do not have any experimental information. In fact, I'm suggesting to nuclear experimentalists to look for it. So that will, once such a halo state is identified, then we can go back and see whether reaction involving that halo state, nuclei in the final state, can really enhance the cross-section, or even help core fusion. Now there has been many known, not many, several known long range force. This is one example. If you bring a two charged particles, they polarize each other, and it's called the electric polarization of a target, so that it creates some effective new force. And that force goes like 1 over R force instead of 1 over R, instead of Coulomb force. But it's known to be too weak to help core fusion. And furthermore, this is a real part of potential. See, we are looking for imaginary part of long-range force, or long-range force in the imaginary part of elastic scattering potential. There are so-called ephemeral state, nearly zero-bound three-body state, that can give a long-range potential, but again, it's a real. Only known other imaginary long-range potential is this type. If you make order for Coulomb excitation of target nuclei and ask what is the elastic, the imaginary part of elastic potential, then you get this kind of behavior. It's called the dynamic polarization potential. So we are essentially adding another one, which I showed before. We haven't named it, but it's another type of range potential. So it becomes no more fiction. It's a real thing. We are deriving it, and experimenters should look for it. Once we find, we can go back and see whether nuclear reaction cross-section involving that nuclei has an enhanced cross-section. Okay, so we are in the right track as far as the theoretical argument is go. Now, given near cancellation of gamma factor, can we explain all this anomaly which is being observed or claimed to be observed? Plus, I didn't add transmutation, but transmutation should be added here as well. And I'll go some of them one by one before time runs out. How many minutes do I have? 5. Only 5?
Yes.
Okay, so I have to be very quick. First of all, one of the objections initially was how could you cancel gamma factor? Now, that objection I answer with our theoretical papers. But that's if that is accepted or accomplished, then what about this? How can you explain this? I suggest 2 possibilities. One is this channel has somehow target nucleotide tritium, has long-range imaginary part in elastic channel. Then this will be enhanced, but not this one. This is just scenario. I'm not saying this is a definite candidate. Other possibility is that tritium neutrons produce other fusion reaction, presumably mainly producing this and not producing neutron. Now, if you look at that point of view, there's lots of interesting consequence. If you ask whether by near cancellation of gamma factor, can you make this go? And you cannot, because Q is negative. That is what I'm saying, that even if you overcome Coulomb barrier, this is not going to be mechanism for producing tritium for the experiment involving palladium. On the other hand, if you are putting in an electrolyte lithiums, then this goes, but this will not, if you overcome the Coulomb barrier. And of course, this decays into helium plus proton. Now, this type of thing can be tested if you use pure lithium and pure lithium-7. Every time you see tremendous tritium coming out of your experiment, like Professor Bockris does some time ago, you can always go back and see whether you can repeat that with either lithium-6 or 7. And if this indeed turned out the case, then maybe this is a very strong candidate. Now, I can suggest many samples like that, but because of time limitation, I will just limit a few cases. You can ask me about more later. What about non-nuclear acids or radiation? You can invoke final state with a heavy nucleus. Then you don't really see nuclear acid as such as proton or tritium, but you see the new element. And this one even you don't notice, because if you're using lithium-6 and 7 together, you don't notice whether this is being generated until you check it. And furthermore, if Q barrier is extremely small, like in this case, the brainstorm radiation from this final nuclei is going to be very minimal. So you can look for, this is just example, but you can look for certain cases where Q barrier is small enough that kinetic energy of final particle is so small that brainstorm radiation may be minimal. And of course, you can always look where the proton-induced reaction is possible. You see, once you overcome this near cancellation of gamma factor, there is no reason why we cannot exclude the proton fusion. And another good example of proton fusion is P-gamma reaction. There are lots of positive Q barrier floating around. And this is a very interesting case where potassium can go to calcium. If it goes to excited state, this is extra excited state, stable one here. This kind of thing will not really produce too much, there won't be enough kinetic energy to produce lots of brainstorm radiation. This can decay then into going to ground state, emitting another type of gamma ray. And of course, if you look at the some of nuclear spectra, it's mind-boggling. There are so many states. If you go to palladium, it's more complicated. And if it turns out any one of them is loosely bound state, then you got the near cancellation of gamma factor. It could happen over the periodic table. Heat after that. If you produce some of the nuclei which has a shorter half-life, example is given here, then of course that will decay slowly so that you still continue to produce heat. And finally, let's see whether we can generalize this to multi-particle fusion. Kasagi had a paper published a couple of years ago claiming that this is taking place. And we did generalize our two-body model to three-body model. Again, you can accomplish gamma factor cancellation under certain conditions as we did for the two-body case. And this morning, George was talking about negative Q for this, but after lunch, after talking to George, I looked up the table, and you can have a positive Q value if this is the mechanism. We don't know, but this is the positive Q value. If somehow you can formulate three-body program similar to this one, and then invoke near cancellation of gamma factor, then this could be one possible way to explain how silver is produced. So I and my colleague have lots of work to do. We are pursuing this, and let me conclude then by saying that more general formulation generates this enhancement factor, which can lead to cancellation, near cancellation, not the exact cancellation. And it's the imaginary part of elastic channel which will do the job because of the optical thing. And one of the latest paper we show that theoretically there is we can derive such a force if excited Haro state exists. So it's now for experimenters to find such a state to support this conjecture. Once this is found, then our theoretical derivation is vigorous. That is, it says it will happen. Let me see any other comments. And I think looking back, entire this field, I feel it's reaching a stage where we can really follow this standard scientific method. That is, lots of people observing it, and you come up with a theory which is being done somewhat, and then test And if it fails, you throw away and come up with a new theory, and then repeat all over again. And I believe this process is taking place in this community now. Thank you.
Thank you.
I'd like to make a kind of critical comment and then ask you a question.
Yeah.
The critical comment is about the Ni plus S plus O, by which you got the positive Q. I mean, how do you imagine that in a solid you will get a significant coming together of 3 foreign atoms? It seems very, very improbable.
Yeah, unless there is a gamma factor cancellation, that's impossible.
Yeah, but you'd have to have diffusion, just their coming together to be there.
Oh, that probability is okay if you have a solid densities. Or
You have to have a very large one.
see, if you try to do a beam experiment,
Oh, yeah.
then what you said is correct. But remember, all of this, what you have your side is density of particles or flux, which is enormous. You can't, you know, in the tokamak people are trying to get the 10 to the 14 particle ions per cubic centimeter. Now we're talking about lateral numbers. That's what helps. And that's your side. I mean, without that, I don't think no one believes that this is going to happen. So,
second thing that I would like you to say a little bit about, there's been much evidence at this meeting today that when you have a really concentrated number of protons in palladium, protons and neutrons, you can get a large number of new elements.
yeah.
Please, can you comment in view of your theory why you can get 10, 20
Yeah,
elements?
I have to start speculating. This is my speculation, the scenario. Once Yarmov factor can overcome, there's no reason many reactions can occur.
Yeah, I feel
That's my speculation. Including Monty's type. Although I don't believe you.
Yeah. I understand how you treat the amplitude with this
Yeah.
kind of approach. You can read
Yeah.
imaginary part, you said that there's 0 at infinity. How do you treat the phase at infinity? I don't understand the boundary conditions.
Phase?
Yes.
Oh, whether the amplitude plus minus.
Right.
Yeah, we can. Yeah, we can decide when we write the formula. I didn't say, but we can go back to T matrix and putting actual, let's say, square wave S wave square wave plus Coulomb. We can analytically, for that case, get the phase out of it, not exact, overall expression.
Correct. But you must make any prediction. You must set the phase at infinity and such and such.
What phase? I don't understand. I thought you were talking about phase of imaginary amplitude.
Right.
What phase are you talking about? No, that's a convention. Phase in this expression is uniquely determined. No questions about it. Okay? This derivation shows.
This is not the question. Okay. You must have boundary conditions, right?
Yeah.
So,
No, just a second. Boundary condition is when you try to solve a Schrödinger equation.
okay.
We're not doing that.
Okay.
Okay? So there is no problem with the phase.
Okay.
Any question? Okay, so thank you again.
Okay.
Кстати, непримиримые борьбы которых мир так и не получит новые источники дешевой энергии.
Cold fusion and hot fusion, here are two antagonists whose uncompromising struggle will either produce new clean sources of cheap energy and help the world overstep the threshold of the third millennium under the banner of new physics, or prolongate burning huge sums of tokamaks.
Эта борьба происходит и в ваших лабораториях, когда в своих ячейках ЯС вы наблюдаете, качестве продукта реакции, элементы, частицы и явления, характерные якобы только для высокотемпературных ядерных реакций.
The struggle takes place in your laboratories as well. When you cold fusion test cells, you observe reaction products, such as elements, particles, and phenomena allegedly inherent solely in high-temperature nuclear reactions.
Это чаще всего тритий, гелий, серебро, железо, хлор, избыточная энергия, а также протоны и нейтроны.
Most often among these are tritium, helium, silver, chlorine, iron, excess energy, as well as protons and electrons.
Общим для всех разнообразных ячеек ХЯС является то, что материал для конструктивных элементов и их групп вещества выбирается произвольно.
The variety of cold fusion cells all have a joint in the armor. The structural materials and reacting substances therein are chosen arbitrarily.
Попытки объяснить протекание процессов, существующих в реальных явлениях, идут от результатов. Тут и катализ, и электролиз, и химические сродства и так далее.
The attempts to understand the nature of the processes and the phenomena observed stem concomitantly from the results.
Я же твердо убежден.
We have heard about electrolysis, catalysis, chemical affinity, lattice induced phenomena, and the like.
Я же твердо убежден, что это подкреплено множеством воспроизводимых экспериментов, что основой наблюдаемых явлений, так называемого холодного и горячего ядерного синтеза, является низкотемпературная трансмутация без радиоактивности.
As for me, I am absolutely positive and have abundant reproducible results to support my conviction. So-called cold and hot fusion phenomena are the outcome of radioactive-free low-temperature transmutation.
Этот процесс в материальных объектах определяется их природой, величиной электрических полей зарядов плюс и минус, постоянно взаимодействующих пространственных электрических полей.
In material objects, this process is induced by their nature. Presence of minus and plus electric charge fields, which interact continuously with the special electric field.
Именно эти три взаимодействия управляют всеми процессами как во Вселенной, так и в малых устройствах, на малых устройствах.
It is those interactions that govern all the processes both in the universe and in our devices.
Мои многочисленные эксперименты не оставляют никаких сомнений в том, что направленное манипулирование усиленными пространственными полями интенсифицирует все производственные процессы.
My numerous experiments unambiguously suggest that controllable manipulation of the artificially intensified spatial field promotes transmutation.
Я предлагаю вам провести со мной мысленный эксперимент с обычной тестовой ячейкой ХЯС. Повернем ячейку из общепринятого вертикального положения на 90 градусов.
I invite you to join me in the mental experiment with the ordinary cold fusion test cell. Let us bring it from its conventional upright position A through 90 degrees into position B.
Перевернув таким образом ячейку, вы убедитесь в том, что во втором случае количество продуктов реакции будет значительно больше за счет сложения полей только в эксперименте по перевернутой схеме.
In thus doing, under the same low temperatures, you will witness the increased number of the reaction products, owing to the summed-up field in the cell with the special field.
Длительные эксперименты на перевернутой таким образом похожей установке подтвердили, что это обеспечивает рост продуктов, которые я себе позволяю назвать продуктами низкотемпературной трансмутации.
Numerous experiments in the likewise arranged device substantiated an increase in the reaction products that I would let myself name the product of low temperature transmutation, of fission but not fusion.
Результаты работ и полученные образцы были представлены на прошлогодней конференции.
The results along with the samples were presented at the last year conference.
Пространственное поле, не учитываемое экспериментаторами, решающим образом влияет на все материальные объекты.
And the spatial field, ignored currently by the experimenters, exerts dramatic impact on every and all material objects.
Она вызывает низкотемпературную трансмутацию, которая протекает при разных, но только низких температурах.
It provokes transmutation, which takes place under different but necessarily low temperatures.
Так, например, при температуре 36,6 градуса взаимодействие пространственного поля с углеродом С13 в нашем организме вызывает его распад в С12, что и свидетельствует о старении организма человека.
Thus, at a temperature 36.6 degrees centigrade, the spatial field interaction with carbon C13 in our bodies causes its decay into C12, signaling the human body's aging.
Такое вызывающее заявление не может быть принято на веру, не будучи подкреплено серьезными аргументами. К ним я и перехожу.
Such a challenging statement cannot be trusted unless backed up with serious arguments. To these I shall proceed.
В общеизвестном факте, что Вселенная состоит из положительных и отрицательных зарядов, не хватает одной маленькой детали – единства мнений о том, что же это за заряды.
The widely accepted fact that our universe consists of positive and negative charges lacks one tiny detail, anonymity of opinions as to what are these charges.
Я покажу дальше, что они могут быть только и исключительно электроны и позитроны.
I will show later on that they can be only and exclusively electrons and positrons.
Известные сегодня науке так называемые элементарные частицы, лептоны, гипероны, бозоны и подобные им, ничто иное, как промежуточный продукт высокотемпературной бомбардировки ядра.
So-called elementary particles known today, leptons, bosons, hypertons and the like, are nothing more than the intermediate products of high-temperature bombardment of the nucleus.
Они не существуют в природе стабильными, подобно электрону и позитрону.
They have no natural stability, like electron and positron have.
Только у электрона и позитрона удельные заряды и наибольшие среди известных сегодня свыше 300 элементарных частиц призраков.
Electrons and positrons stand alone among over 300 elementary host particles.
Они неуничтожаемы и заполняют пространство произвольно, но их распределение в пространстве остается неизменным, ибо пустое пространство диэлектрик.
They are unexterminable and fill the space at random, but their spatial distribution is never changed because the empty space is dielectric.
Взаимодействуя, электрические поля этих зарядов суммируются, образуя соответственно пространственные заряды позитронов плюс и электронов минус.
When interacting, electric fields of these charges sum up to form respectively spatial charges plus of positrons and minus of electrons.
Пространство между зарядами заполняют электрические силовые линии, самообразованные из электрон-позитронных пар нейтрино.
The space in between the charges is imbued with electric field lines self-emerged from numerous electron-positron pairs, or neutrinos.
Они своими конечными зарядами Q нейтрино плюс 0,16 на 10 минус 42 степени кулонов и Q нейтрино плюс минус 0,16 на 10 минус 2 соединяются соответственно с пространственными зарядами плюс и минус и образуют пространственное материальное электрическое силовое поле.
Their terminal charges Q equals 0.16 times 10 minus 42 coulombs, and Q minus equal 0.16 times 10 minus 42 minus 42 coulombs. Connect them respectively to the spatial plus and minus charges. And in this manner, the special material electric field is self-emerged.
В нем и происходят все физические события и объекты Вселенной.
It is in this field where all physical events with the objects of the universe take place.
Заряды электрона и позитрона составляют их непознанную сущность. То, что в Библии называется логосом. Вначале было Слово, и Слово было в Бога, и Слово было Бог.
The charges of electron and positron are their uncognized essence, something called logos in the Bible. In the beginning was the Word, and the Word was with God, and the Word was God.
То есть эти заряды несут в себе и создают при взаимодействиях с полем всю информацию о любых явлениях, от гравитации до перестроек решеток.
That is, these charges store and under interaction with the field give out all the information about any phenomenon, from gravitation to restructuring the lattices.
Их взаимодействие первично.
The interaction is primary.
Оно изначально всегда наиболее сильное, взаимно парное.
It is primordial, always the strongest twin reciprocated.
Самопритяжение зарядов рождает самодвижение электронов и позитронов. Самосоздается сплющенная электрон-позитронная пара, материя, нейтрино.
Self-attraction of charges yields self-motion of electrons and positrons. An oblate electron-positron pair matter-neutrino is self-emerged.
Рождается большая скорость сближения этих пар, и выделяется энергия при их соударении.
Great velocity of attraction between those pairs is born, and energy is released when pairs collide.
Нейтрино, как материя, обладает зарядом 0,16 на 10 минус 42 степени кулона и массой. Масса нейтрино 0,43 на 10 минус 34 степени килограмма.
Being a matter, neutrino has both charge Q plus minus equals 0.16 times 10 minus 42 coulombs and mass M equals 0.43 times 10 minus 34 kilograms.
Так как заряды Q дельта минус и Q дельта плюс не уничтожаемы, то соответственно и масса не уничтожаема. Напомню, что массу я определяю как меру направленного взаимодействия неуничтожаемого электрического заряда с пространственным полем.
Since Q delta plus and Q delta minus charges are unexterminable, hence mass is also unexterminable. Let me please remind you that I determine mass as the measure of the directional interaction between the non-exterminable electric charge and special field.
Поэтому нейтрино не гипотетическая частица, как утверждает современная физика, а реальная, неуничтожаемая материя, основа мироздания.
Therefore, neutrino is not a hypothetical particle, as modern physics states, but real, non-exterminable matter, the basis of the universe.
Из множества нейтрино самопритяжением полей их микрозарядов самостоятельно создается нейтрон N. Рисунок 2P. Сокращать, да? 5 минут, хорошо.
From multiple neutrinos through self-attraction of their macro-change field, a neutron N is self-generated. Figure 2b.
Из нейтрино строится нейтрон, протон, из протон-нейтрона строится пара нейтрона. Пара протона и нейтрона. Так, переводите, только не по тексту. Из нейтрина строится протон и нейтрон.
Proton and neutron are constructed from neutrino.
По существу протон и нейтрон это одинаковые частицы.
Essentially, the proton and the neutrons, those are the similar
Только протон,
particles.
только протон отличается положительным зарядом позитрона.
But proton has a positive charge as different from positive.
Чтобы доказать, что действительно, начиная от водорода и кончая тяжелым элементом, в качестве доказательства строится таблица Менделеева.
As a proof of this, the table of Mendeleev, periodic table, has been built.
Так, да. Таблица Менделеева показывает, что таблица Менделеева показывает, что все элементы периодической системы строятся только из нейтрина.
The periodic table shows that all the elements of the periodic table are built from neutrino,
Плюс электроны и позитроны.
plus electrons and positrons.
Таким образом, все элементы в мироздании состоят только из этих четырех частиц.
Thus, all the elements in the universe are built from those four kinds of particles.
Что он говорит, да? Нейтрино и электроны
Neutrinos and electrons,
нейтрино, антинейтрино, электрон и позитрон являются основной материальной массой, создающей любой объект Вселенной.
so electron, positron, and the neutrino and antineutrino, they build all the matter which is constructed from positron and similar.
Таким же образом образуется тяжелый элемент.
The same way, the heavy element is built also.
Скажем, уран.
For example, uranium.
При образовании урана выделяется выделяется энергия.
During the uranium fusion, the electric energy is released,
Которая, передаваясь орбитальным электронам,
which is accepted by orbital electrons,
ослабляет их связь с ядром,
and the connection between those electrons and nuclei is weakening
действием пространственного поля
by the action of a spatial field.
электрон снимается с орбиты тяжелого урана.
Electron is leaving the orbit of heavy element,
И начинается распад при низкой температуре, трансмутация.
and low temperature fusion transmutation takes place.
Процессы образования шли от точки А к точке Б к точке С. Процессы трансмутации идут от точки С к точке Д к точке А. То есть по кругу мы выделяем нейтрино, электрон выделяется, позитрон и антинейтрино.
So the formation of matter taking place by this cycle from A to B to C, and then the decay of matter taking place by this other route from C to B to A.
Процесс в мироздании идет круговой. Непрерывный процесс созидания и непрерывный процесс трансмутации.
There is permanent process in the universe, the process of creation and the process of transmutation.
Важно отметить, что трансмутация начинается в области низких температур тяжелых элементов.
It's necessary to point out that transmutation is originated in under the low temperature conditions in heavy elements.
Это взаимосвязанные процессы.
Those two processes
Круговые.
are interconnected, circular process, permanent process.
И некоторые выводы только
And there are
сделаем.
some conclusions I would like to make.
Некоторые выводы. Отсюда. Нет, почитай.
I will just read
До
it.
конца.
Unexplainable bursts of temperatures up to the utter destruction of test cells strongly suggest that resulting from heating-induced low-temperature transmutation, a new element has self-emerged in the cell accompanied with the excess heat as byproduct. Thus, I claim that only and exclusively low-temperature transmutation provides a new source of cheap and ecology-friendly energy. And this is the basis for physics of the future. Transmutation of super heavy elements in their massive aggregations in the universe always involves liberation both of energy and lighter elements and their gaseous derivatives like hydrogen, helium, methane, ammonia, at the pre-finite stage of their finite transmutation into the charges A plus, A minus, Q delta plus minus, Q delta minus plus. Electric charges are the products of transmutation, the very dust of which the Bible says, "For dust you are, and to dust you will return." That is why numerous expensive attempts to fuse heavy, long-lasting elements at temperatures as high as tens of millions of degrees are hopeless. Violated by high temperatures and tremendous energies, nature will never engender sound offspring that is cheap, abundant energy. New, inexhaustible sources of non-polluting energy he will obtain who utilizes the spatial field energy, along with the artificial combination of natural low-temperature cell generation of elements and transmutation processes. As soon as these days we can diversely use energy released during transmutation in bodies, substances, I have conceptual designs of the devices that help utilize the energy of fission particles to obtain heat energy in the units made pre-included constituent of heat generating circuit of the heat power plants, and enable immediate production of electric energy as byproduct of low temperature transmutation. To make the above statement valid, the experiments were initiated in February 1995 were lived underwent transmutation and temperature equals 780 degrees centigrade and barometric pressure. Invariably reproducible results show, besides new elements, microcurrent of electrons from the transmuting lead.
Я хочу обратить внимание на последний эксперимент. Два слова. Последний
Just
эксперимент
couple more words, the last experiment,
несколько парадоксальный.
kind of paradoxical.
По идее, мы со свинца должны были получить группу элементов, расположенных выше.
According to the commonly accepted
С весом несколько меньше. Да. Да.
according to the commonly accepted
Несколько меньше веса.
rules, it was expected that we would obtain from lead some elements with some lighter elements with less weight.
Начальный вес нарезки элемента составлял 6,28 грамма.
The initial weight of the element was 6.18 grams,
Конечный вес элемента составлял 6,6 грамма.
and the weight of the product was 6.6.
Элемент пошел от плюмбум, от свинца вверх, таблицы Менделеева, а вес его увеличился. Это может быть только в случае, если элемент там осмий. В действительности проведенные анализы показали, это был осмий. И в прошлом году мы получили доктору линию.
So, and the experiment shows that the element which was produced by this reaction was osmium.
Да. И в прошлом году мы для контроля передали образцы доктору линию для того, чтобы подтвердить действительно, что наше определение в наших лабораторных условиях было справедливым.
And we gave some samples to Dr. Lin in order to confirm that our determination of the elements was valid in our lab.
И как побочный продукт распада свинца шел электрический ток.
And the electric current was formed during this reaction.
Все, спасибо за внимание.
That's it. Thank you.
First, I want to say thank you to Dr. Bockris, Dr. Miley and Dr. Lin to invite me for this meeting. The object of my research is a study of atom behavior in nature in relation with the synthesis of super heavy elements. Okay. I will talk briefly of the source of this research. You will find more matter to think about in my paper. Nevertheless, I want to show you written facts. If you see this, the source of the research is so controversial. Experimental fact I observed doing experiments. An explanation how could be created super heavy element, and I strongly insist on something like the energy balance, because I think the conservation of energy is very important. I don't want to invent something, energy X, to facilitate how it works. I will talk about my experiment I did and what I should do. And I will present an evidence I have here. Now, the source of the research, I decided to present this. If you read all the treatises of alchemy, you will find here, it is 1670, and you have a description made by somebody. He said, I saw in the fixation of mercury on all that we have done, mercury never made any kind of noise or explosion. Well, we must note that the fixation made in the presence of mercury in crucible was done in a quarter of an hour, and then the powder used by the alchemist was white. The important fact is that he was using something, a compound, because it cannot be a pure element. It was a compound, drop in mercury, and this mercury, after a while, was converted by strong fire into a ponderous compound that looked like silver, but nitric acid had no effect. Well, here you see that in fact it is platinum. So it passed from 80 to 278. He used a white compound. Here you have other description made in 1831 by CNE. So I took 100 grams of mercury and he put 1 drop of his powder. He increases the fire and he gets gold. Also here he used a compound, if you read the treatise of CNE, the transmuted sulfur is red. You have 1 compound, 2 compounds. It is, I think, a very interesting fact. Well, there is a property I have deduced from various books. The phasor pattern is red or like ruby. It's very ponderous. And there is a point very important. When you read this treatise, they told you that they wrap the powder into paper or into wax, and they drop inside. I was thinking that the wax was a way to slow down the neutron, because you need neutron to make the transmutation. In fact, if it is the compound is very ponderous and you drop it inside, if you want the compound to react, it must go inside, because as the mercury is boiling, when you put it in the boiling mercury, it explodes. And the proof of what I am saying is with Sidani, who is talking about cold mercury. He has oil, he produces the sulfur as oil, and he drops one drop of the oil in the cold mercury, and it does the transmutation. In this case, the mercury was cold, the reaction did not start. And why the reaction start? It is because we have a compound of mercury, of element I named super heavy elements, that is a fluoride. When you put it in the mercury, you have a breaking of the chemical bonds, and you have the free elements that explode. And it is why I have to prove. Bon. They could told me, oh, that only talk. Here it is a way to understand all treaties. This is a treatise named Sanguis Naturae. I got it in Seattle, University of Washington. You can make a copy. And they're talking of water. We want to see what is this water. We may interpret it very easily. I will read what I hear. To draw the water out of a rock may be related with fluoride, because the association water-rock gives flowing rock. Fluoride word comes from Latin fluere, that means to flow. It is said that chemistry is used to treat the rock. That is to say, you use common method, especially action of vitriol. People use a lot sulfuric acid upon the rock, which is clearly precise by the regulation of fire as described in all chemistry books. It is good to read the treatise of chemistry of Nicolas Lemery, who describes the regulation of fire exactly as here. You start slowly, and after you go strong, and after very strong. And the reason when you have sulfuric acid and you attack, for example, sodium chloride, the first acidity of sulfuric acid is strong, so no problem, you evacuate chloronic acid. The second is very hard to get, so you have to eat stronger. It is the explanation. Here it was just source, and you see it's a lot of work because you have to read a lot. And after, there is a fact. The first experimental fact has been obtained in 1986. At that time I knew that pitchblende and fluoride are required by the process. I had to understand, so I decided to observe the variation of gamma activity when doing react the uranyl salt obtained from pitchblende with hydrofluoric acid contaminated with silicofluoric acid. A geometric gamma centrometer has been used to follow daily the gamma activity of the mixture and of the first extract. Here it is the first extract, because I have the mixture of pitchblende directly treated with nitric acid. Well, I evaporate, I get a dry compound, and after I put a little hydrofluoric acid contaminated, you mix well, and you put that on the sun during 5 days. And after 5 days, you have a separation of a liquid phase, you recuperate the liquid phase, and you put the liquid phase in the refrigerator. Very important. And you may measure the activity. And you will see how you get a very strong change. Alors, what happened is here. I put the flask with maybe 50 milliliters in the refrigerator, and the day after I observed a strong variation of the needle of the centrometer was going crazy, but not with a sample of uranium mineral. So I observed that during 2 days, and I decided to go to measure neutron at the laboratory of the university. And you are going to see what happened. Yeah. At the beginning, it was 2,500, and I get one peak of 10,000, and after a very big peak, a burst of radiation, it was neutron. To detect this neutron, it was easy. Huh? It was a label counter that has been used in association with a gamma tube wrapped in a silver foil. Fast neutron have been slowed down with paraffin. It was a system used by a professor of physics of plasma to detect the emission of neutron from plasma. The eye counting has been set by Frickerson, this professor, on me. For me, it has been an interesting proof that was something. It is a fact, but I have to explain it. So the question is, from all treaties of alchemy, I identified the basic mineral, but sure, there is no doubt they were using pitchblende and fluoride and photocarbon too. I do an experiment and I observe that the experiment gives me something very abnormal, because I understand when you have enriched uranium or plutonium in solution, you have burst of radiation. You may say, okay, there is a point, a critical point, so explosion, but with uranium mineral, it is not enriched, it is natural, only a product of decay of uranium, one. So I was thinking how. In one step, you can't. In several steps, that means you make one fusion with light element and the other, very low probability, because one is separate, impossible to. The synergism, I think it's that. On the energy source. Alors, we have to produce something with more energy available than the initial material, because the problem is here. We start from uranium, it has a certain amount of liberable energy, around 200 MeV, and we are going to get super heavy elements. We will have a lot more of energy, because if you break the chemical protections, you get a beam of pure proton neutron. It is a lot more of energy. So how, with few energy, to get more? So it is necessary a synergy. And the path to obtain that is here. You have a neutron produced by reaction alpha with light element present in the medium. You have a fission of fragments that may collide uranium present in the medium. So you have a question of how much element you have. It is a reason it is important to have two phases. If you have one phase, only a liquid phase in the system, or a pure solid phase, it doesn't work. And you have a transfer of kinetic energy to uranium, and uranium becomes a projectile. The maximum energy received by uranium is here. The life amount may be 85 on 95, and the energy maximum on 80 on 82. The condition for fusion is here. It is the reverse of the condition normal, because we have a EV projectile. So we have to see how it works now. here are value calculated by Seaborn. When we, for light elements, we know, okay, it was 82 maximum for the energy. So we see that the maximum, the elements that may be close to the target is oxygen. From oxygen to beryllium, there is no problem. And fluoride inside may not react, may not be close enough to produce fusion. It means when both nuclei are in contact, they have a possibility to get to form a compound nucleus. If they are not in contact, bon, I think there is no way to get that. And we see that all reactions have a Q value negative, so it could not work. So now we are going to see what is the trick. The trick, if we cannot get fusion, is here. You must get a mix of two kinds of nuclear reaction. One kind of exoenergetic nuclear reaction of proton absorption, and the second kind of endoenergetic nuclear reaction with light element fusion. It means that the projected uranium, as soon as it exists, it travels in the medium. The medium is very rich with protons, so it may encounter a lot of protons, a minimum of 100. And it may encounter light element. So in the case of a fusion with boron, the first proton here, second the free here, and each time the projectile gets energy, and here is the Q of formation with the light with boron, and we get the minimum value of the projectile is this. And after the excitation energy is this. It is a process that should occur very quickly, because it is not one fusion with a proton on it rests little time. No, it's something that should occur very quickly in order to produce release the super heavy element. And now I have to give the experiment I did recently. What I did, I measured the nuclear activity, and I was interested by the composition of the mixture, because there is one thing very important. If I want to establish a correlation with all treaties, it is the color they observe. They say they observe a black color, a green color, a blue color. So it was very important to see that with uranyl salt. So it depends on the chemical composition. Alors, I took the spectra because I had not the possibility to get the complete measurement of daily as I did before. And you will note here, you have a peak around 50 Kelvin. Here are the descendants of uranium. Here you see the same, taken few hours later. I get that. Alors, the mixture was again outside. Alors, the first spectra has been taken after the mixture stay outside in the cold of the night, during the night. I took the spectra in the morning, and after I put the mixture in the sun, and I took the spectra 4 hours later, and I get an increase, and the increase you will see here. that. So I was surprised to observe that. And it has become stronger day after. I was checking too what happened when I have a lot of liquid phase. In the case, I have a lot more of fission, this peak being barium X 32K. Yeah. I did counting. Alors, the counting I did here, the mixture was in a cold place. I took the mixture at 11 p.m. and I decided to make the counting. Now, if you check, I have 70,000 and here, bon. I jumped from 70,000 to 2 millions. 3 millions here. Yeah. Very strong jump as a cure, maybe 12 half hour after I started the counting. And I did the spectra in the morning. I got a peak like the other. I did some counting on the peak. From a cold place up, I get an increase on the channel of the peak. If I do a microwave heating, I get a slow increase, and it means if you eat too much, you break something, and after you get nothing more. So it's good to slowly raise the temperature, but not too much. If not, you break something. And what happened one day when I use the microwave, I put the mixer inside, and after 1 second heating, the microwave stopped. It refused to start again. So I put the mixture in other place, and after the microwave started again. A point regarding color, a blue color with a uranium salt. Well, I have been able to obtain that blue color. It is quite different from uranium salt you have here. That's something I have to see why. In fact, the composition of the mixture is very important. So here it's okay. Here is a pure uranium salt, uranium nitrate, no, acetate. So it's different. So I have to see why this is here. Alors, I will give you one maybe an evidence of what happened with a photo. On the first, it is photoradiography. On a filter paper, I put 1 drop of uranium solution. The first, there is 5.6 micrograms of uranium. The second, 11.2 here, 16.8 here, and 22.8. So the question is, what is responsible of this blackening? So it may be explanation cosmic ray, that coincidence, I don't think. So it's possible that is a superhuman credit inside that disintegrate and gives that. Here you have a small, you see, it was very low concentration of uranium. I did the test once more, and I got that. But concentration are different. I have 86